Alright class, today we're going to be talking about the distance from a point to a line. Now let's say we just have a random point and a random line, and we want to see how far is this point from that line. Well, from what you know is that we talked about last videos that you could draw line segments from the point to the line and measure that line segment to figure out how far away the point is from the line. And as you can see here, that it just can't be any line segment, because as you can see here, no matter what line segment I draw from the point to the line, I get different length line segments. So which one is the distance? Well, when we talk about distance, we really are only talking about the shortest distance. And the shortest distance from a point to a line is the perpendicular distance from the point to the line. And this is something we discussed in our notes from the last video. So there are two questions that may naturally arise. First of all, how do you construct the perpendicular line segment and not just any other line segment? And secondly, how do you measure the length of that line segment without a ruler? Well, we're going to discuss both of these during this video. But what does it mean for lines or line segments to be perpendicular? Well, one of the things that we discussed earlier in the semester is that if lines are perpendicular, then their slopes are negative or opposite reciprocals of one another. So the slopes of perpendicular lines are negative reciprocals of each other. So for example, if the slope of one line is negative 3/4, then the slope of the line perpendicular to it is going to be positive 4/3. So in other words, we change the sign and we take the reciprocal, i.e. we flip the slope. Well, in order to figure out in this example what the perpendicular line segment is, we first have to determine what is the slope of the original line, and then from that, then produce a line that has a negative reciprocal slope for that to be the perpendicular line. So the first step in order to construct the perpendicular line segment is to determine the slope of the original line. And then after we determine the slope of that original line, then we're going to determine the slope of the line that's perpendicular to that line. So let's review what we know about slope. Well, from our notes from page 67, we know that the slope of a non-vertical line is the ratio of the vertical change to the horizontal change. In other words, rise over run between any 2 points on the line. And we also know what different types of slopes look like. Negative slope falls from the left to the right, as you can see here in line J. Positive slope rises from the left to the right, as we can see in line K. Undefined slope is for vertical lines, and zero slope is for horizontal lines. And what we also talked about earlier in the semester is that if lines are parallel, then that means they have the same slope. So any two vertical lines are parallel, but any two lines that have the same slope, M1 is equal to M2, means that the lines are parallel, and we indicate that by the little parallel markings. But for the slopes of lines that are perpendicular, we know that their slopes are negative reciprocals, or another way to look at it is if I multiply the two slopes together, I get a product of -1. And even though we don't have a slope value for vertical lines are perpendicular to horizontal lines. So we, even though we can't use this multiplying their slopes together in this case, what we do know is that for non-vertical lines, if we were to find the slopes of the perpendicular lines, we can multiply the two slopes and we get -1. Or they're basically negative reciprocals. So in order to determine the slope of a line, we have to determine the rise over the run, and that's a quantifiable thing. So it's best to have, since we don't have a ruler, it's best to use a grid. So we add a grid and then determine the slope. Remember, it's the rise over the run between 2 points. So let's just pick any 2 points on the line. And then we're going to figure out the rise over the run. And you guys may remember how to calculate the rise over the run. In this case, this is the rise is vertical and the run is horizontal. But again, we do not have a ruler, so we can't measure this using a ruler. So we're going to have to add some axes so we can add coordinates for these points and use a coordinate formula to figure out the slope. So calculating the slope using the two points on the lines, we use this formula that you remember from Algebra 1. And we do that, we see that the value of the slope of the original line is 0.92. Okay, if you want to represent that as a fraction, then the slope of that line is going. So when we calculate the slope, we get the slope of line 1 is 0.92. And if we convert that to a fraction, the slope is really 23/25 simplified. And if we convert that over to determine the slope of the perpendicular line is the negative reciprocal. So that means that the slope of line 2 is negative 25/23. So now let's go about creating lines that are perpendicular to the original line. Well, the tricky thing is that there's more than one line that is going to be perpendicular to the original line. In fact, there's an infinite amount of lines that are going to be perpendicular. So which one are we going to pick? Well, there's only going to be one that we should use, and that should be the one that goes through the original line and the original point. And that's that line. So all the other lines fail because we only want to use the ones that's perpendicular and goes through the original point A. So in order to determine what that line is, we should write an equation of that line. A line that is perpendicular to the original line and passes through point A. Well, there are several ways you can write the equation of the line. You guys are most familiar with the slope-intercept form, but in order to use this form, you need to know not only the slope of the line, but you also need to know where the line crosses the y-axis, which we really don't have access to the exact location as far as that's concerned. So to me, my favorite form is the point slope form, because all you need is a point that's on the line and the slope, and we have both. We have the slope of the line and we have the coordinates of the point that's on the line as well. So if we write an equation of that line, we can have it in this form. So here we have the equation of the line that's perpendicular to the original line. It has the slope of, sorry, there was a typo. But anyway, it has a slope of the line that's perpendicular, which is negative 25/23. And it has the points, which are coordinates of the point A, which had coordinates, x coordinate of 1.68 and y coordinates of 2.12. Now later on, you can display the equation in slope-intercept form and can convert that if you so choose, but this is sufficient. So the next step that we have to do is we have to measure the length of the line, this line segment that's created by the perpendicular line segment without a ruler. Now the tricky thing about that is, in order to first, now that we have the perpendicular line, we need to find the line segment. In other words, we have to determine the coordinates of the point that intersects both lines. And we can determine that by solving a system of equations. And then after we find that point, then we have to use the distance formula to find the distance between point A, our original point, and the point we just found. Now if I have a graph, I can easily tell you the point where the two lines intersect by just drawing the point where the two lines intersect. But what if I don't have a graph? How can I determine that? Well, the way you determine that is by solving a system of equations. We already have one of the equations, which is the equation of the red line, and now all we need is the equation of the black line. Now usually they will give you the equation of the original line, but even if they don't, you can easily find it by using the point slope form. We already know the slope of the original line was 23/25, and we can pick any of the points, like for example point C, where we use to calculate the slope, and write the equation of a line. So now we have these two lines that we need to find the intercept of, and we can solve this by using one of the three methods you learned in Algebra 1 to solve system of equations. You can solve this using elimination, using substitution, using algebra, using graphing. Any of those methods is sufficient. And in the interest of time, we won't take time to review that. But once you have found the coordinates of that point, so once we basically take the coordinates of both our original point and our intersection point of the 2 points, and we find the distance between the 2 points by using either the distance formula or Pythagorean theorem, and we come up with our actual distance, which is, so I have a tool that will calculate that quite easily by just selecting the 2 points And then we have the distance between the two. As we can see here, the 2 is 4.25. And you will get that same using the distance formula.